Hello, this is Sarah Hardy at the University of Maine at Farmington, and this is a video tutorial in using Rcmdr to look at chi-square tests. Okay, so to start with, we'll look at this example that we looked at in class, and we are looking at the null hypothesis that the variables being in a relationship and living in the dorms are independent versus the alternative that those variables are dependent. Okay. Now, as is often the case when looking at two categorical variables like this, we don't have the raw data in spreadsheet form, where we have the data for each observation. Instead, the data has already been summarized in a two-way table. Okay, when that is the case, what we want to do is go to Statistics. Contingency table is another name for these two-way tables. And in this case, we're not going to select two-way table. We're going to select the one that says Enter and Analyze two-way table, because for this one, we'll be able to enter those numbers from our table. Okay, so to start with, we want to make sure we have the right number of rows and columns, which we can adjust by clicking in these bars. We actually have 2 rows and 2 columns. Notice that we're only using the data, not the totals. Okay, so I'm putting it back because we have 2 rows and 2 columns, and I'm going to enter my counts in here. 38, 63, 80, and 42. Now you can also, and this is not necessary, but it's often very helpful when you're trying to look at your output and figure out what's what. So I'm going to enter in some column headings for this. So this one is no dorms and yes dorms, no relationship, and no, and yes relationship. Okay, now we also can compute percentages, and again, this is not necessary. The default is no percentages. Sometimes it is helpful to have it print out either the row percentages or the column percentages. So I'm going to, just to show you how that works, I'm going to compute the row percentages for this. Okay. For our hypothesis test, we want to do a chi-square test of independence, and let's also print out the expected frequencies. And so I'm going to hit OK. And the output we get, okay, starts by repeating the table, so you can check to make sure you've entered your data correctly. And then it shows us those row percentages. And so what we can see here is that of those who are not in a serious relationship, about 62.4% live in the dorms. Okay. For those who are in a serious relationship, only 34.4% live in the dorms. Our p-value is right here, and we can see that it is 3.15 times 10 to the negative 5, which means we need to move that decimal place over 5 places, and so that gives us 0.4 zeros in a 3. So in other words, a very small p-value. So we're going to reject this null at any test level, even 1%, and so we'll reject the null, and we can conclude that we have evidence that the variables being in a relationship and living in the dorms are dependent. We can also see our expected counts down here, and these are the expected values we would expect to see in these combinations if the variables were independent. Okay, for my next example, I'm going to look at one where we actually do have the data in spreadsheet form, or at the observation by observation level. Before I get started on the second example, I'm going to clear this window. That's not necessary, but sometimes it helps you keep your output straight. if you've already cut and pasted that where you need to go. Okay, so I've already selected my data set, and this is some data that was survey data collected at UMF in '02. And so just so you can get an idea of what this data set looks like, each row is a different survey respondent, and we've asked them a variety of questions similar to the ones that we are asking in the survey that we're doing right now. Okay, so I'm going to now go again to contingency table. This time I'm going to select a two-way table because I'm not going to enter the Okay, so the variables that I'm going to pick here are, first of all, gender, and secondly, dessert, and I think again I'll look at row percentages, chi-square test of independence, and I'm going to print the expected cell frequencies. Okay, and okay, so what we see here is, okay, so what we have here are the row percentages. So for example, 38.3% of the women prefer chocolate cake versus 40% of the men prefer cheesecake. But we see here that okay, so what we see is we have a p-value of 0.72, a very large p-value. So we are not going to reject the null hypothesis, and we're going to conclude that we do not have evidence that these variables are dependent. Okay, it's easiest to actually graph this data with Excel. So I'm going to now actually go over and open an Excel spreadsheet. And I've already entered the data in here. To do the graph, we are going to select the data, go to Insert, go to Column Graph, and then go to 2D Column. Okay. If you're going to print out anything ever in black and white, it's always best to actually use the grayscale. And what we see here is that the default is that they actually have given us the percentages, for example, that prefer apple pie, cheesecake, and chocolate cake. That makes it a little hard to think about because we have so many more females than males that obviously we have larger females in every category. So in this case, we actually would rather look at a graph that has male and female on the x-axis and then gives us the percentage that prefer the different desserts. So if we want to just switch it, you can just go up here, switch row and column, and that shows us now, we can see that, well, more females prefer chocolate cake, more males prefer cheesecake. We can also, if you want to improve your graph, you can go over here to chart layout, for example, and select this one, and then you can insert a title. Okay, so that is about it for the chi-square tests.